Hello, in this lecture we're going to start on SQL. This is going to be chapter 3 from your textbooks. Okay, so data definition language, short for DDL, allows the specifications of information about a certain relation. So this includes the schema of each relation, the types of values associated with each attribute. So this is going to be the type of data type that we have to indicate. And physical storage structure of each relation on the disk. So I'm sure you guys are familiar with these different types of data type. These are the allowed data types in SQL. So char is for character. So in parentheses, there's going to be a certain number. So this is specifying the length, the maximum length that is allowed. Okay, we also have varchar, variable character string. It also has an n, so this is the maximum length allowed. Okay, we also have integer. Small integer is an integer, but like it's a smaller number. Okay, and numeric, so this allows decimal points, and it's going to specify exactly how many is allowed. So p is, we have p comma d. So so the first number 3 means that it's going to allow exactly 3 numbers. Doesn't matter if it's before or after the decimal point, it's going to be 3 numbers total. And then the next number, it says 1 here. It means that it's going to allow up to 1 number after the decimal point. So here we see that 44.5 is allowed because it has a total of 3 numbers, 4, 4, and 5. And it's showing exactly 1 number after the decimal point. Okay, so this would not be allowed because this one has 4 numbers, not 3, right? So because of that, this would not show. And then we have 0.32. It's showing 2 numbers after the decimal point, which we only allow up to 1. So that's also not correct. We also have real, double precision. We also have floating number. You can also specify the precision at least n digits. Okay, so when you're choosing these numbers, make sure it's something that makes sense. So for example, if it's someone's last name, you want to pick, a smaller enough number where you don't want to take up too much space or waste it. If you have like 20 characters for someone's last name, most likely you're not going to see a lot of people with their last name being, 20 characters long. But you also want to have don't want to have it too small where it's 5. And if you put in a value that is greater than 5 characters, it's going to cause an error. So make sure you pick the right values for these n's. So we're going to be creating a table using the keyword create table. So whatever you see bolded, these are going to be the keywords. So create table, and then the name of the relation, we're going to call it instructor. And then in parentheses, you're going to list all of the attributes. And it's going to be the name of the attribute, space, there it's not comma, just space, and then the data type of this attribute. So ID is going to be a character string of up to 5. So it's going to be a number up to 5. We also have name. Okay, name is going to be varchar's character string, a variable string that allows up to 20 characters. And I'm guessing this name most likely is a full name, or it might be last name actually. It's probably last name. Okay, and then department name is going to be up to 20 character string. Salary is going to be a numerical value. It's going to allow up to 6 numbers, and then it's going to show 2 numbers after the decimal point because it's going to show how many cents, right? So this probably means that it's assuming that instructors don't make 7-figure income. Okay? So you can indicate that an attribute is a primary key. We will also talk about foreign keys. Foreign keys are keys that's referencing another variable in another relation. Okay, not null means that it cannot be null. It has to have a value. Okay. So here, let's take a look at how we can create an instructor table. Create table, name of the relation, open up parentheses. Okay, here we see that we have 4 attributes. We have ID, name. Okay, name cannot be null. There has to be a name of the instructor, department name, and their salary. And then you have a comma, and then here we're going to list the primary key. So primary key is, again, it's bolded. It's going to be a keyword. parentheses ID. So ID here is the primary key. Okay, comma, we have a foreign key called department name. And this department name is referencing another table called department. Okay. Here we are creating a table called student. Okay, it has ID, name, department name, and total credits. Okay, and then total credits will allow up to 3 numbers, and then if there is no decimal point. Primary key here is ID. It has a foreign key, department name, also referencing department. Okay, create table takes, which has ID, course ID, section ID, semester, year, and grade. And we can see that the ID is going to be a five character string. Course ID is going to be 8, section ID is 8, semester is 6, year is, it's just 4, right? Because year. Grade is going to be 2. Primary key here is not just ID alone. ID is the ID of the student, right? So this student took whatever course and whichever section during which semester and which year. So all those things together is unique, and that makes a primary key. Okay? And then the foreign key here is ID is referring to, it's referencing the ID from student. Okay, and then another foreign key, we have course ID, section ID, semester and year, and then this is referencing another table called sections. You can also insert rows of data. You can delete from a table. You can drop a whole table, like just by deleting it. You can alter table by using these keywords. So you can do insert into instructor table and then values. So it has ID number, last name, department name, and salary. So the order does matter. If you were to switch these up, it will probably cause an error, okay? Because we're trying to put in the 66,000 as the department. That was the third one. And then the fourth one is salary, but we're trying to put in 66,000 as that. So make sure it's in the same order. You could also delete from student, and then you can remove all of them. You can remove certain rows. You can drop a whole table using drop table R. Okay? And once you do this, you will not be able to find this table R from your database. You can also alter. So this is the basic query structure. It's in English, so I feel like this is a lot easier than relational algebra. A lot of people find this easier. It just makes more sense. You don't have to deal with all those symbols. So select, okay, and these are going to be the list of all the attributes. So whatever attributes that you do want to see, you're putting it here. You're listing all those here. From, and then these are going to be a list of all of the tables or relations. In relational algebra, these were just placed inside parentheses at the very end, right? But with SQL, we just have it under the from clause, and then where, and then we have some kind of predicate. So this will be your condition where you can have, you know, something is less than or equal to, greater than equal to, not equal to, equal to. So those kind of, any kind of Boolean expression will go here. Okay, so select from where. Okay, so we can select name. So this is attribute name from instructor, and this will return the list of all the names from the table instructor. And in SQL, notice that it is case insensitive. So here, a name with the capital N, and everything is capital name, and all lowercase name. These are all equivalent. So it really doesn't matter if they're all uppercase or lowercase, they're considered the same. Okay, so we have select distinct, department name from instructor. So by default, SQL does return all of the duplicates. So if you don't want to see any duplicates, such as you just want to see, you know, which department names can be are from instructor, you run it, and this is what you'll get. Unless you specify select distinct, that it will get rid of some of these duplicates. So like you see computer science here. So like this one will not be listed here. This will also be, it's a duplicate. So this will, you will not see this one. I'm seeing finance here, and so this one will not show up. So this will return only the distinct ones. So by default, you will see duplicates. So actually, you could just select all, but you actually even don't even need this all. Just by doing select department name, it's gonna automatically show all the duplicates. Okay, if you want to show all the attributes, so instead of specifying I only want to see department name or I want to see department name, comma, salary, if you want to see every single attribute from that table, you just use this asterisk symbol. So select asterisk from instructor and this will list all the attributes from table instructor. Okay, you can also have a literal from clause, so select 437 is an option. So this result is a table with just one single column and one row, and that will have a value 437. You can rename this by using the keyword as. So select 437 as food. Okay? So you can give it a name for this column. Okay? And you can select A for instructor. Okay? So the result is a table with one column. It will have n rows, number of tuples in the instructor table, and each row will have a value A. Here we have select ID, comma name, comma salary over 12. So you can have any kind of arithmetic expression here. So salary is how much you make in a year. There are 12 months in a year. If you want to know how much you make in a month, you would just divide that number by 12. So this will actually show your how much you make in a month. Okay. You can also rename this to be called something else. So here I can do select ID, name, salary over 12 as monthly underscore salary. So now this column will have a name, monthly salary, and it's going to be dividing the salary by 12, and it's going to show the number that they're making in a month. Okay, the where clause is where you specify some kind of condition. Okay, so here I have select name from instructor where department name is equal to computer science. Okay, so it's going to be any kind of condition. Here we're using an equal sign. It could be any kind of expression, any kind of comparison using any of these. So less than, equal to, not equal to any of those. Okay, you can have multiple conditions, just like we did in relational algebra. So here I have select name from instructor, where department name is computer science, and so it's not any of those weird symbols, it's just English and. So that's why people find it easier. Okay, and salary is greater than 70,000. Okay, you can have multiple relations in the from clause. Okay, so select asterisk, meaning select everything. We want to display all the attributes from instructor, comma, teaches. Okay, so this comma means that we're taking every single possible combination between instructor and teachers. So that's going to be the same thing as Cartesian product that we dealt with in relational algebra. Okay, you could have more than two tables. There's really no limit on how many you can have. But we can also do natural join, which is what we talked about. So we'll go into more detail on the different types of joins that we can do. But this in comma is Cartesian products. Yes, we want to find the names of all instructors who have taught some course and the course ID. So we have select name, comma course ID from instructor and teaches. So we are combining these two tables. So if we didn't have this where clause, it will be returning every single possible combination. So it wouldn't matter if the particular course was taught by a different instructor. It would just return every single combination. But by having this where clause where instructor.id is equal to teachers.id, this will return only the courses that this particular instructor has taught. So it's returning, the instructor's name and the course that they have taught. Okay? Here, the only difference is that we want to find all the instructors in the art department and all the courses that they have taught. So the only thing that was added here on top of this is this line where we have and instructor.department name is art. Okay, you can use rename operator. So we have done this in relation algebra, right? It was the P symbol, we call it row. Here, it's just keyword as, which is easier. So you have old name and then keyword as, which is bolded, and then the new name here. Here I'm doing select distinct t.name from instructor table as t. So we are doing a Cartesian product between instructor and instructor. because we're comparing their salary, we want to find out all the instructors who have a higher salary than some instructor from computer science. So we're comparing them. So we're doing a Cartesian product between the two tables, instructor and instructor. We want to be able to distinguish them. So we're going to rename these to be called T for the first one and S for the second one. Okay, so now we want T that salary is greater than S that salary. And then we want this instructor S to be from the computer science department. So as long as T's salary is greater than at least one person from the computer science department, then they qualify, so their name will be returned. Okay, so keyword as is optional. You can also just do simply instructor space T, comma, instructor space S. Okay, so this is equivalent to this. You can just omit the S. Okay, so it's really up to you. Okay, so this is a self-join, right? So we have a relation called employee supervisor. So this person, employee Bob, is being supervised by Alice. Susan is the supervisor of Mary. David is the supervisor of Alice, right? So if Alice is supervising Bob and then David's supervising Alice, David is also kind of supervising Bob, right? So it's going to be like a big boss kind of thing. So can you find all of the supervisors of Bob? Okay, you can, right? So let's go into the different types of string operation. So we couldn't do this in relational algebra, but in SQL you can. Okay, so this is called string matching operator. So there are two different options. One is this percentage sign, and one is an underscore. Okay, so this percent sign matches any substring. So this percent sign could be anywhere from 0 character all the way to infinity. And underscore kind of specifies that it can fit exactly one character. Okay, so if we want to find the names of all instructors whose name includes the substrings dar. So we want to include the substring dar, meaning we could have something before dar, we could have something after, or we could have something in front and after dar, right? Okay, so select name from instructor, where name, and then we use a keyword like. So this attribute name is going to look like, and then dar. Okay, so you could have something before dar, something after dar, or both, or none, because this percent sign indicates any size substring, and any size means it could be 0 to many, right? Okay, so it's going to contain the substring dar. Here you could also have something like name, select name from instructor where name is like, and then you have 100, and then this is the percent sign. So we use the escape backslash. Okay, you can also find patterns. Okay, patterns are case sensitive. So here, intro, and then we have this percent sign. It means that it's going to begin with intro. There's no percent sign before. So it's going to start with intro, and then you may or may not have any other substring following intro. So it's any string beginning with nitro, or intro, I mean. Okay, the next one has percent sign, comp, percent sign. So it's any substring that contains the word comp. So you could have something before, after, or both. Okay, so we have 3 underscores in a row. So this is going to be any substring that has exactly 3 characters because each of these underscore indicates that it's going to be exactly 1 character. And since we have 3, this means that it's going to be any string of exactly 3 characters. Here we have 3 underscores followed by a percent sign, any size substring. So we'll have at least 3 characters and possibly more. So this means that it's going to match any string of at least 3 characters. You can also support different string operations such as concatenation. You can be converting from lowercase to uppercase, finding the length of the string, and extracting certain substrings. Okay, so here we have some exercises. So since a lot of these might look familiar to you because we have done the exact same ones in relational algebra, but this time we're doing it in SQL. So just remember the structure of SQL query is going to be select, and then followed by select, it's going to be a bunch of attribute names. if you want to display everything, it'll be just the asterisk symbol. Okay? And then you're going to have the from clause, and following from, you're going to have a list of relations. It could just be one single relation, it could be multiple. And then you're going to have follow that by where. The where clause will be followed by some kind of a predicate, which could be any kind of a Boolean expression, less than, greater than, equal to, not equal to, equal to. Okay, so let's try number 1. Find the salary of employees who work at Coyote Quest. Number 2, find the manager that manages Pamela Reeve. Find the names of employees that live on University Parkway, San Bernardino. Okay, so just go ahead and pause this video and work on these 3 queries. Okay, once you're done, you can go ahead and click play again. Okay. So for number 1, let's first think about which table this information is contained in. So we are looking for an employee's salary and their workplace. Okay. Actually works at Coyote Quest. Okay, so what would that be? Okay, so it can be found in works, right? Okay, so I'm going to do select salary from works because it contains the employee's name, which company they work for, and how much they make, right? And the where clause will have CNAME, the company name, is equal to Coyote Quest. We find the manager that manages Pamela Reeve. That can be found in manages, right? Because it has a manager name. Okay, so we're going to do select mName because we're looking for the manager from managers, where eName, the employee name, is Pamela Reeve. Okay, number 3, find the names of employees that live on University Parkway, San Bernardino. So we can see that we have the street and city information from this table. So we're going to do select name from employee, where street is equal to University Parkway and city is equal to San Bernardino. Okay, number 4, 5, and 6. Okay, so find the names of employees who works at Cosmopolitan that makes greater than or equal to 70,000. Number 5, find the names of companies that are not located in the city of LA. Number 6, find the name, street, and city of employees whose name begins with J or K. Okay, so go ahead and pause it and work on these problems. Okay, so let's go over it. Okay, so we are looking for employees who works at Cosmopolitan and then their salary information. We already know that that can be found in the works table. So we're selecting eName because we're looking for the names of employees from works, where CNAME is equal to Cosmopolitan and their salary is greater than or equal to 70,000. Okay, we want to find names of companies that are not located in the city. So that will be company table, which has the CNAME and city. So we're selecting CNAME, name of company, from company, where city is not equal to Los Angeles. Okay, the last one, we have select everything because we have name, street, and city of employee. Okay, and from employee table, okay, where name, like. So this is a keyword. A name is kind of like, and it has a J, so it starts with a J and then followed by some kind of substring, or K followed by some substring. Okay, so whose name begins with J or K.